wasn't faster, is there any chance that B will catch up with A if they left at the same time? Is it possible? Is it possible for B to catch up with A if B was not going faster than A? No. If A is in front of you, if A is in front of B, B must be traveling faster than A to be able to catch up. So it'll take an hour in this case. Any question? So there are, again, two major type of questions. You'll actually see some of these in a minute. Okay, are we good with these? No? Questions? Yeah.
No, I get it.
You sure? Well, like I said, we're going to do some of these in class. I'm going to give you some problems. And thanks to Miss Moon, she typed it for us. I don't think it was Miss. No, it's another. I think it was another teacher. She's not here anymore. But anyway, thanks to other teachers. So I'll show you that in a minute. It's called round trip. So whenever they talk about round trip, anybody have any guesses to what this might be?
Oh my god.
Yeah.
It like goes and then.
Yeah, you go somewhere and come back. Exactly right. So let me try to hide this thing. So for example, A goes up somewhere, maybe a mountain, as 25 miles an hour, and come back down in 50 miles an hour. And I keep saying this is important. What's going to be same in this problem? Because that's important in this. Yeah, the distance is going to be same. Why do you think I keep saying what's same and so forth? Why do you think that's important? Why do we have to know which two things are same or something? Anybody? No, why? No? Okay, you see why. Okay, when we do an example, hopefully that would, because it's important to understand the distance is same for this because, anybody? That's fine, we'll get there. Okay, so, as you can see, yeah, you have an idea? Okay, all right. So for example, if this is 50 miles, the round trip, right? If the place you're going up is 50 miles and coming back down is 50 miles, how long does it take A to get up to the top of this? Yeah.
2 hours.
2 hours is correct. How did you know that?
Because if you're going 25 miles.
Yeah, if you're going 24 miles an hour, in 1 hour you go 25 miles. So if you want to go twice as much, then you. What about for coming down for B? How long does it take for it to come down 50 miles? Yeah, 1 hour is correct. So this time the time for A and B are different, right? But what about the distance for A and B? They're both same, so you gotta keep that in mind. Okay, and so when you see round trip kind of question, keep that in mind because that's going to help us to come up with an equation. That's why we need to know what's same. Remember what's an equation? Where left side of an expression is same as or equal to the right side of an expression, right? So when you have a round trip, since we know that the distance is same, that's how we're going to come up with an equation. So kind of keep that in mind when we come up with an equation. Okay, any question?
Wait,
Yeah.
isn't it mean round trip? So wouldn't A be like 4?
4?
Like 4 hours?
No, the distance. Yeah, the distance is going. The whole thing is 50 miles. So yeah, in this. Yeah, not 4.
But is B only going down?
I mean, it could be going up and down. It could be like going from LA to Paris or something, like plane. That's still round trip. By the way, one thing to keep in mind in round trip is when we talk about round trip, we always take the same route. Okay, don't think that what if they took a shortcut or something? Okay, unless they say something like this. Round trip, the distance that they're traveling is same exact distance coming back and going there. Does that make sense? All right, so keep that in mind. And also, this is where people get messed up too. When they talk about round trip, some question says, they left at 12 p.m. or something, right? Now, is 12 p.m., do I use 12 as my time? No. 12 is just when they left, okay? Don't plug in 12 as t. That t represents amount of time that you travel, not like when you left. Okay, it doesn't matter when you left. You could have left at 12 or 1 o'clock or 2 o'clock. Doesn't matter. Does that make sense? So don't get that confused on your homework. Another thing I want you to be careful is they talk about like 15 minutes or 20 minutes. Could we use 15 and 20 as the time when their rate is like miles per hour? No, you need to convert minutes into hours. Because if you use 15, what does that mean? Does that mean 15 minutes or 15 hours? 15 hours, okay. So you see that in a minute when we do some of the problems. Anyway, so when, of course, when you do these, do you think having this sort of chart is helpful for us? Yeah, whenever we talk about rate and time and distance, you know, and there are two types, you're gonna see this chart. And if you, even if you don't, it's going to help us to organize our data. When you use this chart, rate times time equals distance, okay? So are we ready for some of these problems? Okay. Like I said, we have type problems. Let me give it to you right now. So let's look at example 1. Who wants to read for us? Number 1. Austin, go ahead.
2 witches leave on their brooms from Rosemary at the same time. One flying east at 550 miles per hour, and the other flying west at a speed of 650 miles per hour. How long will it take them to be 2,000 miles apart?
Okay, now it says motion picture. What do you think that means? I want you to do, yeah. I don't want you to draw any witches on there. That's not what I need. I need actual, you know, the first of all, is it opposite direction, same direction, or round trip? Yes. Opposite. Is it type A or type B for this one? This is really important because that picture is going to help us come up with the equation. Anybody know, is it going towards each other or is it going opposite from starting at the same point? 1, 2, William? B, type B, where they start at the same point. Go ahead and try. And solving is actually your homework for tonight. I want you to come up with an equation, first of all, okay? So draw the picture, fill in the chart, and come up with an equation. Everybody try, go ahead. And you're right, it is opposite direction, type B.
You made a typo.
Sorry, go ahead. And by the way, yeah, it is 4.8, not 4.7. Sorry, it should be 4.8. So first of all, did you guys get the motion picture this way? They start at the same point. They're both going opposite direction, right? The other is going faster than the other, right? 650 miles an hour, 550 miles an hour. Okay, this is the opposite direction, type B. Are we okay there so far? Now, no, but yeah, if you draw the picture, I know which type you're talking about, so that's fine. But for homework, I do want to see the picture. Okay, so what's my unknown for this one? Anybody?
Time.
Raise your hand. Yes. Time for? Exactly. I like you to be this specific. The way that Aaron said, the time for 2 witches to be 2,000 miles apart, right? Now, who knows then? So for the chart, did you put down east and west, something like that? That's what I did. Okay. And I declare my variables down here. I'll show you that in a minute. What did you write down the rate for each of these? Yes, sir. 550 and 650 miles per hour is correct. What about for time? What did you guys put down for time? Yes, sir?
Oh, I didn't put that.
You didn't put that yet?
Yeah, I didn't put that.
Oh, what goes into the time there for both of these? Yes, sir, Victor?
The results like
X for east, and what about for west?
X minus.
X minus, is that what? X minus 100? We're talking about time. You're looking at the rate now. You're subtracting. What do you think, sir? Huh? Oh. Blake? Vlad?
Is it 2,000 minus x?
Is it 2,000 minus x? What does 2,000 give you? That's the distance. Why is distance going into the time place for time? Ethan?
It's the same.
It's the same.
Yeah.
Why is it the same, guys? Raise your hand. Raise your hand. Raise your hand. Why is this is important? Why do I put T for east and T for west? Kaylin.
Well, they start at the same time and they meet at the same time, so it wouldn't be that one travels longer than the other.
Yeah. Well, they don't meet, but they'll be 2,000.
Sorry.
Yeah. They'll be 2,000 miles apart, right? After they travel same amount of time. Does that make sense? You see what? Because they leave at the same time, don't they? From the same point, and we just want to know when they will be 2,000 miles apart. Therefore, right? The person going east and the person going west, it'll be same amount of time for both. Don't put down like some of you did T minus 100. That's for rate, right? Their difference of rate is 100 miles. That has nothing to do with the time, right? Does that make sense, guys? In place of time, the unit has to match, right? Everything has to be an hour. Rate, everything has to be in miles per hour, and so forth. So then, what's the distance for east? Yes, sir. No.
Oh,
Audrey?
1,000?
No. Do they both have to travel 1,000 each? No, not necessarily, because one's going faster than the other. What's the distance for? Yes. 550 T. You just multiply these together, guys. Isn't that the distance? That's why we did all this work, right? Rate times time gives you the distance. What about the west, Alvin? 650 X or T. I did T. And as Aaron said, this is how we declare our variable. T is how long it will take both of them to be 2,000 miles apart, and it takes them same amount of time, don't they? Even though one will be traveling less distance, right? The one that's going east is going to travel less distance because the rate is slower, but that doesn't matter, right? After certain time, they're going to be 2,000 miles apart. Now, then here's the important part. Any questions so far? Do you know why we have the same T? Maybe I should highlight those. Okay. Do you know why we have same T for both? Okay. Now, what's then going to be my equation? 1, 2, 3, 4, 5, 6, 5. 5 people know? That's it? Who haven't I called? How about I called all of you. I haven't called. Yeah, what do you think?
550 T plus 650 T equals 2,000.
Yeah, excellent. That's correct. Aren't they all talking about distance? Isn't 550 T distance for the person going east? Isn't 650 T the distance for the person going west? So when you add them together, there are 2,000 miles. And 2,000 miles, is that distance, rate, or time? 2,000 miles. That's just distance. Miles, distance, right? So we know from looking at their units. So when you add them together, you get 2,000. Now, do we know how to solve this? Yeah. Okay, you do that for homework tonight, because I want to go over other questions for now. Is that okay? Are we everyone okay with these? I would like you to then flip the page over, because number 2 is really similar to number 1. You could do that at home. Flip the page over. Let's do number 3. But I would like you to circle 15 minutes. What do you think on number 3? You see where number 3 is? Let's see. When you flip the page, number 3, do you see where it says 15 minutes there? Why do you think I want you to circle that? Anybody have an idea? Victor, why do you think I want you to circle that?
Because it's your time.
Huh? It's my time, yeah, but why do you think I want you to circle 15? Especially the minute part. Why do you think I want to choose? Glad?
Because you have to convert it to hours.
Yeah. If you don't convert this into hour, look at your rate. Rate is kilometers per hour, you see? So that means your time must be in hour. If you use 15, what does that mean? 15 hours. Okay, so if you use 15, that means you're using 15 hours, which will kind of make things wrong. Okay, so make sure, by the way, how many hours is 15 minutes? Anybody? Yes. 0.25. I like to use a fraction though. You could use that, but what would that be as a fraction? 1/4. Okay, so anyway, go ahead. Try to. And do you think drawing the motion picture is important? Yeah, go ahead.